Alright, so this is the Siglent SDS1104X-E, which Rob from Tailbacker Technologies has kindly loaned me to do a review on, and hopefully you enjoyed the video and learned some information about how to use it and what features it has and that sort of thing. It does have some little quirks and you have to be a little bit aware of, just for user interface side of things and how things feature, how the features work. So Bode plot is probably one of the hardest ones to get right. I've spent a little while on this one trying to figure this place out and understanding the quirks and even how to set it correctly. Right, so this is probably one of the harder features to use. I'm sure that'll evolve in time. So as you can see, I've got a Bode plot going now, but I've got, because it's not a great test setup. This thing's like strung together and it's just like a mess. So it's just showing it roughly, right? But yeah, we get to see this anyway, and I'll go into detail about this. So thanks again, Rob, for sending me this, and obviously this will be returned once I've finished doing the review. So don't forget to go and see Rob if you're interested in one of these scopes. 4 channels for the price. Good stuff. Right, so I thought I'd just play around with this scope a bit more, and I've just got a little pulse signal coming in here. Just make it a bit broader. Now, this navigate function here and this section here is new-ish to me. I don't know. It's actually fairly easy once you understand what it does. If you're using segmented memory or something like that, you can actually step through the segments, or it will do a time stepping, or like going through the history or whatever, depending on what you're doing. Alright, so this has got 3 frames in here for current settings, because I've got the memory set at 7 megabytes. So how much you actually have available, it depends on what you got. But these are all going to look very much the same because they're the same. Alright, so it's I've got 3 there and all basically the same thing. Alright, so this is the waveform doesn't change, so you're not going to see much difference on the screen there. Okay, but the navigate option, and lets you choose different options here as well. So of course I've got history open, that's open now. It gives me the history frame, so I can then step through with this. Alright, but like I say, it's going to be the same because of, you know, it's the same. It just skips through each one. Right, we'll step through in turn. If I have history turned off and then go to navigate, now I've only got time option. If you have the search option running and then go to navigate, and you have to do something else too. What was that? You get the search event come up at the same time. I need to be able to do it. Is it history at the same time as search? Is it? Yes, there we go. History at the same time as search. Then you can go search event instead. Alright, so always go the wrong way with these knobs. Always go the wrong way. So that I can be searching through the events instead. Alright, and it shows you the numbers there. Alright, it will step through. Alright, so that's all easy. No problem at all there. Now that's a little handy little menu. I mean, if you've got segmented memory and using that for getting samples off, then that's going to be really handy and actually quite important to have. The other stuff in here is math. Is to turn that off. Math bring up. I've got FFT already turned on this channel, so you can see there's a little section there which is quite interesting. So let's just bring the center over, and again I need to turn the thing the right way around. So interesting, this has got a bandwidth. It shows quite a broad bandwidth on here. I've done a bit of a bandwidth test on it, and about 300 megahertz is where you actually start to see it responding. You start to see data here in the FFT. So anything above that just drops off. So even though it shows it on the screen, obviously the front end isn't actually capable of doing that frequency because it is only 100 megahertz scope, you know. So you kind of expect that, and you bring it right down like that. Okay, gone a bit too far. So there you go. You can see some data in here. All right, for the FFT. So there's a bit of noise in this signal here, and the FFT is showing it up. Handy. Okay. So this shows like 500 megahertz in that time base. 1 gigahertz, right? But as you can see, it's nowhere near that coverage on there. So just because it displays it on screen doesn't mean you should actually expect it to do that. It's obviously like a universal software you can have, and it's well firmware, and it just does it regardless. But yeah, I mean, 250 megahertz per division, 1.2 gigahertz. No, you know, don't expect to do that. That's just unrealistic. Okay, and it scales with the horizontal time base as well, so that's also convenient. Let's just bring this down a bit. Probably a bit too much. Yeah, 5 megahertz a division should do. But yeah, it's just a little playing. I mean, I've FFT is something I've used a lot of. I've played with it a little bit, but not really that much. I mean, it is fairly fast as well, as you can see. It's not bad at all. If I turn the knob the right way, it always helps too. Right, so yeah, it's alright. Can't complain. Also got a split screen as well, so you can also go full screen if you want, so it just does a full display. Overlays them. Exclusive turns off the channel view, but only just gives you FFT. And also back to split screen again, so you got DBM and VoltRMS, DB VoltRMS, external loading, 50 ohms, just the one. Make sure the is an option. Yeah, same thing. Reference level, you can set that as well. Actually, that external load, is that adjustable with this? Yes, it is, that's why. Right, so it's obviously for reference there, that's why it's there. Put that down to 50. And also you've got these other math operators in here, like you always do, as you typically find, you know. Addition, etc., multiplication, division, delta time, sort of stuff. So square root, yeah. I don't tend to use any of those functions. The addition subtraction ones, they're handy if you're having to do like a cheats way around having a isolated probe. Oh, what's the word? Oh, it's gone out of my head. Anyway, you can stick 2 probes onto a circuit, a positive, negative, and then do a maths calculation there to give you the final waveform. Yeah, it's just a way of doing it. If you don't want to, if you can't use the earth on your probe because you got a live chassis or there's a voltage difference or something like that, you know. Anyway, so the other thing this has got is decoding built in as standard. I don't have anything hooked up right now for doing decoding. I might set up the test unit later and so you can see the decoding working, but that's a standard option on this. It's not extra, I believe. It's built in. As standard, you don't have to pay anything. Utilities, so self-count system status, so this is the information in case you're watching, and software version 7.6.1.12. Single exit, and sound beeper, you know, as you always get. It's very similar to all the other Siglent ones. Language options, pass-fail setup, you can do that as well, so you can set up the waveforms on pass-fail in this. Channel selections, operation off and on. Like, it's not something I've ever used, so it'll display up here as well. And this is the mask setting, so you can then tell it how you want it to do it. But it's not something I've ever used, but people that do that would probably be familiar with this anyway to know how to set it up anyway, so it's not really something I need to be worried about, I think. Okay. What else is there? Oh, that's right, I've got it plugged in. In-out system, so you got USB TMC for the USB device. I don't no, it is what it is. Wireless LAN, so you can choose which one you're using. So you can use a plug-in Ethernet cable or wireless internet. You can set the IP and DHCP, IP addresses up manually, or DHCP if you want, as down here, right? So you can set it in each of these devices here, or in these buttons. Alright, so this jumps to that section. Okay, I'm not actually using it anyway, so I'm going to be using. Oh, go back into IP set. DHCP be back on again. No, just turn it back on. So I use DHCP anyway, most of the time. There you go. I'll save that. Wi-Fi setup. So in here you can find networks. You can do a turn the Wi-Fi on for a start, and then you can do a manual scan, and it will check for wireless networks. Now this is using a little USB thumb drive device, little plug-in module, which is on the back right now, and there is a certain one which is specified by Siglent, and it happens to be this one here. Now you can get them from Siglent, but you can also get this one, TP-Link. Alright, same model number apparently, and it's supposed to work. I haven't tried it connected to my network yet, but I haven't given it a go, but it's fairly cheap. Alright, so that's what it looks like. Okay, so simple enough. These are some nearby networks, and this is my one here. So I haven't actually tried connecting it because my network's all restricted. It only allows devices on which are known to the network, which are saved on it, so this won't let this on. I'll have to add it to my network and go into that later on. But yes, that's all simple enough too. Bode plot, and this is creating some interest. So, because I believe Keysight, I think it is, has got Bode plots on theirs, and this isn't something I'm that familiar with myself. I understand the theory. It's yeah. So you have to have the AWG turned on, right? So that plugs in either the USB on the front or USB on the back. It has two USB ports of this type, the USB A's. Obviously, one's for the Wi-Fi unit if you use that, and the other's for the AWG, which I have here somewhere. Right here. So this is the AWG unit for it. Okay, so I shall be doing some testing on this as well. I haven't done it yet. I haven't plugged it in myself yet. Got a USB connection on there which plugs into the unit, and then they can communicate, and you can use this arbitrary waveform generator. So it's a pretty neat little unit. I'm not sure the specs of this yet. I know it's 25 megahertz, but I haven't actually looked at the full specs of that yet. I'm not sure about its output voltages and stuff like that. I'm not sure if it does like 10 volts. I think it does lower voltages. I think it's about 6 volts peak to peak or something. I think you can do. Off from memory, I'm not certain on that. But when I go into that part, I'll cover that in more detail. So yeah, that's that part. So I should go through these menus, I suppose. So you've got the configure menu here. AWG, which obviously isn't currently turned on, so that'll fail if I haven't got that plugged in yet. Sweep options here, so you can set the logarithmic or linear scales, center frequency, span frequency, resolution, low, medium, high, and channel. So you can specify what each channel is measuring here. So device under test, for example, right? But when you've got the AWG plugged in, this is the parallel one, so you have to actually tie them together. So you've got the output from the AWG plugged into the scope, and also go into the device you're testing, such as a filter or whatever it is you're doing, right? So probably a filter, and so that this has like then a reference based on what the AWG is putting out, and then you can see from the other end of the filter as hooking to that, say channel 2 or whatever. You can have multiple stages because you've got 3 more channels to use, and that'll then display this on screen. So I'll do some testing on that, but I haven't gone into it. I haven't tried it myself yet, but that's the theory behind it. But you have to link them together and things like that. So it's just the way it works. Measure range default custom. Yeah, okay. And I think that covers that stuff. Operation off and on, because it's not turned on, so well, it's not connected, so it won't work. Display, so you can do amplitude, dB, reference level, mode, vertical in, vertical out, or voltage in and out. Alright, so you can set these various functions here for the scales and stuff I expect. Auto set phase adjustments, so you want to do that. Auto set as well in there. General auto set as well. Cursors, so you can use those too. Yeah, there you go. So you can adjust them to where you want them to be. You know, X and Y, or probably both, is it? It's X and Y, individual. And you can set the levels here and off which channel it's measured from. So that's all simple enough. So I'll go into that once I actually get the unit hooked up to here and see how that goes. There's something I should mention before I forget about it. When you're using this on your network, there's a feature here. It's only on the 4-channel version. The 2-channel doesn't have this for web control, right? So you can actually log into the scope from the computer. I haven't tried this myself yet, but I will be doing it. And you can basically get an overview of the scope and control it and things like that. So this is something I'll be looking at. So I expect to see that too. So the other thing I need to do is I stopped at the Bode plot for some reason, so I need to move on past that. And you got an update option here for doing a firmware updates, self-testing, screensaver. Times I tend to just not worry about it. If I'm not using it, I'll turn it off again. What time is it still? Yeah, it's just that off 3 to 1 hour. Right, so that's right. Options. So this tells you AWG and install options. Right. Now, I don't know why it's grayed out, but it is anyway. This is the options on this particular unit. AWG and USB Wi-Fi are both enabled, so that's the end of that part. And so that's that section. Web server. Now, when you actually got the internet going, actually I've skipped ahead, haven't I? Did I skip ahead? Options? No, I didn't. Right before, reference position. Now you can set vertical fixed reference or horizontal fixed delay. So this depends on how you're expanding the screen out for the so fixed offset, fixed position, right? Fixed position, fixed delay. So that allows you to, when you're zooming in on these controls here, the vertical or horizontal positions, you can center it so it stays in the middle or goes from somewhere else. It's I have to demonstrate it, I suppose. Power online enabled and disabled. Oh yes, I know what it does. When I apply power to the scope, as soon as it gets power, it turns on. Okay, so I think that's what this is doing here. All right, so power online enable. So power on line. It's not the best English, is it? But yeah, so I think that's what that's doing. So I'll leave that disabled and I'll see if that does the same thing. AWG, which I've now got plugged in, I'll just plug that in. It detects when it's in there. So before you unplug the device, you have to do this as well. Remove it. It's a bit like I'm mounting a flash drive, I suppose. Same deal. So I have this hooked up to channel 1. I haven't used this yet myself. This is going to be the first time. Alright, so let's see what happens, shall we? So output on, we have a waveform. Okay, so there we go. Right, so we have a waveform coming out of that, say 1 kilohertz tone right now. So there you go, yep, 1 kilohertz, 4 volt peak to peak, and sine wave. So you can do square wave, ramps, pulse, noise, DC, arbitrary waveforms. Go to that. So I'm not quite sure. There's obviously a selection here for the arbitrary type. There we go. Stored ones. So if you have one you want to save, and you can do that. And it is a built-in arbitrary waveforms you can try. Currently, you can see it's doing a stir up, which is this one here. So these are the ones that are built in. So that looks, oh, trying to knock the camera over. That looks pretty good. So, you know, obviously you can add your own ones as well, I believe. I think you have to use the EasyScope software, I think it is, to do that. Or if you've got a Siglent waveform generator, the SDG series, I think you can export an arbitrary waveform from that as well and put it into the scope, or you can read it on a scope, save it as a waveform, and then import that into the arbitrary. I think you can do that actually. So if I was trying to simulate a waveform, I could see it, then I could actually save that as a waveform and then load it into the arbitrary waveform generator. So yeah, that's that kind of stuff. So let's go back to sine wave. Frequency, let's see what we can do. Right, so it's nice velocity control in there. That goes up quite quickly if you give it a bit of a push. Right, so 25 megahertz right there. Let's zoom this up. No problem at all. Okay. And amplitudes, so 6 volt peak to peak max. Alright. High level, what does that do? Don't know. No idea. Anyway. So yeah. So, you know, 6 volt peak to peak, that's maybe enough. There's also offset options here as well. Yeah. Low level. Offset. Although I can't see how to get that to work. Maybe not. Maybe it's because I've already got the voltage maxed out. Maybe it's that's why. If I bring that down a bit. Yeah, there we go. So because I had the voltage maxed out, I couldn't do an offset. So that's something you have to watch out for. Okay. So that's all fine there. Let's bring it back down to 0, just because I like to do things like that. It's probably an easy way, but anyway. So that's fine. Loading on the generator, so that's high Z, 50 ohm. Right. Sync output off. Okay, because I'm more than 2 megahertz. So I'm guessing that's like the second port that's on the unit here. I'm guessing it's maybe something to do with that. Right now, what I'm doing is monitoring the actual output of the AWG. So let's change the frequency again. Let's drop that back down. I'll just do a roll mode there so I can see what's going on. And bring it down. Very low there, isn't it? Putting on a bit too low. There we go. See how slowly that can change. There we go. If I go much lower than that, I think it's going to taking too long to change. But anyway, you get the idea. So, right, let's just stick it down. I don't know. Few hundred kilohertz, something like that. Okay, so that's all working fine. Now it's what was I going to look at? 50 ohm, sync output on. I'm not too sure what that's. I think that's the other port. OVP, over voltage protection. Yep. 0 adjust. So I guess that's center 0 and stuff like that. System. That is, tells you about the device, and it's also got firmware update option as well. And remove device. If you want to remove the AWG, you do that. Interesting. So it's unmounted it, but it's still running. Isn't it interesting? So it's obviously it doesn't turn off the output at the time. Right, so now I've done that, but it's obviously the communication side of it worries about. So when you plug it in, when you first plug it in, it does actually detect it and turns the option on. I'm trying to do the touchscreen. It's not a phone. Right, so output on and off. There you go, output on again. So maybe the idea there is if you're going to leave it hooked up and not necessarily use it, is to turn it off first and then do remove, and then done. So maybe that's why I gave the error about the over voltage protection, because the output wasn't turned off. Maybe that's something that Siglent should do, is just have it so when you remove it, it sends an off signal first and then removes it. That's probably something I should do. Alright, so I've got the Siglent hooked up through Wi-Fi to one of my networks, and my computer is also going through Wi-Fi to the same network, and my network's a bit slow in this situation because it's like a very restricted one. It's like a kids one sort of thing. It's held back quite a bit, so it's not as fast as it should be. If I connected us up with a LAN cable, it would be nice and quick, I imagine. I'll try that later on, but for now I just want to show you. So this is the first screen. So if this is in my case, that's the IP address I've got set up, and here we are. So this shows the stats and information about the actual device. I've already loaded a LAN configuration page over here, so you can adjust settings in there, and on the device control you can actually access the scope itself, and this is actually on a Mac. Now normally anything test gear related just doesn't work on Macs. It just doesn't do it. Anything I've ever tried does not work on Mac. So the fact that it actually has a interface which works on Mac is a great bonus, because normally you just don't have this option. So people which use Macs will probably be very happy about this. As far as responsiveness goes, like I say, I can't tell right now because my network's really slow. Not helping the fact I'm trying to upload a video. So yeah, so you can see the screenshot here. You've got various parameters you can change here. I'm currently doing an FFT capture. Now it doesn't automatically refresh the screen, which would be nice if it did, but it doesn't. You just click on this and it'll update. Again, because my network's all quite slow, it's a bit slow to respond. I'll hook it up with the LAN cable directly afterwards and test it again, just do the same kind of thing. You'll see it change in a second when it actually does it. There we go. Alright, so as you can see, I've got one waveform coming in. Actually, what I've done, I've got two probes clipped together using the AWG option, the waveform generator which comes with it. Well, it's an option for the unit, and I've got a capacitor between two probes which is going from the output of the wave generator to input 2, and input 1 is going straight to the output of the generator, so I've got teed off, and so you can see the phase difference there from the capacitor. That's what the capacitor is doing to the waveforms, just in case you're interested. That's why I've got those two waveforms which basically match but are out of phase. So yeah, you got all the various options here for, you know, horizontal scaling and capture modes and that sort of stuff. It's all in here, the same things you get for an actual unit. But so at the moment it's just a bit laggy and slow because my network is not great. And you can choose which channels I'm going to turn on off. I mean, turn the channel on, and we shall see how quickly that applies. I think I have to click that first. There we go. Scope beat straight away. So it's doing some stuff there, and yeah, okay. Let's just make sure it's going down. I don't know if the display's going to update automatically by itself. Try to see what it's doing actually. Yeah, there you go. So yes, it did update by itself. But I've got hooked into other things right now, so let's turn it back off again and apply. So yeah, you can hear it beeping when it's actually doing changes. So you can actually control the scope from here just fine. Let's change the time base, shall we? Let's go slightly faster, 20 milliseconds. So it's sending the commands, it's just getting the feedback through the network quickly enough isn't really there. So let's refresh the screen again. Lost the screen for a moment. So my network's not the best right now for this. But I mean the rest of it's working anyway, so there may be a bit of a glitch there, but that's the most I've seen so far with anything, so just a full refresh if that does anything. Just give it a minute. There we go. Right, so it does work. So that's actually quite impressive. 10 milliseconds. See if I can. You probably hear it beeping. You can see the Wi-Fi signal there on the screen. That's actually on the scope as well. So this is exactly what you see on the scope. So it's no different. Right. Yeah, just playing with that, so don't worry about it. So yeah, it's okay. Now if I do an auto setup, let's see what it does. Okay, that's adjusted itself quite nicely, as you'll hopefully see in a second. But the fact there's a Mac interface, there you go, is awesome for itself. You know, it's good. Let's do this math function off. So some of the more advanced things you can't change in here, like the function buttons. At least not obviously. Yeah, there's no menu buttons in here, but you can send commands. But this is something I don't have a clue about how to do it. If you're familiar with this sort of thing, you probably can do it, no problem at all. But let's do another refresh. So what I'll do is I'll stop this bit here, and I shall plug the unit directly into my network with a cable, and we'll see if it's improves much. Okay, so I've changed this onto my main network now. Just plugged a Ethernet cable in, and it's much faster. So obviously the home page there, same details there. LAN configuration is instant, as you can see now. It's got data there for my network, and this is much more responsive. So let's just change this time base and click apply. And yep, there you go. Updates much faster now. So that's a big improvement. That's more like the sort of speed I expected to do. Don't think it's got to transfer an image and stuff like that, but see what I was going to do. So I turn the channel on, apply that. So it's on. Turn channel 4 on. Yeah, and that's there as well. So yeah, that's all fine. Turn those off again. So let's see what's trigger level, 50% apparently. It's already there anyway, so that's fine. Unstop. There you go, stop. So yeah, the actual scope responds immediately. The updating of the display is a bit slower, but it does actually work. So that's pretty good. Do measurement, shall we? Peak to peak measurement. And IMS, let's do that, shall we? What else can we do? Phase. Channel 1, channel 2. Let's see how it does. So measurements, here we go, phase, 17 degrees out. So yeah, that all works fine. That's what I'd kind of expect. So I'm quite happy with this. This is brilliant to me that this interface works. Basically got the web server built into the scope. I just wish that my SDS 2102 also had the same thing, because that would actually be useful to me. My main computer is a Mac, not a PC, so as much as I'd like to put the thing on my network and be able to do video screen capture and stuff like that of it, when I'm working on things, I can't do that. So because be on a Mac, it's not compatible. So it'd be nice to actually be able to use this on my other one. So if Siglent actually want to add that to my existing scope, that'd be great. Whether it's possible or not, I don't know. It's probably just a firmware thing, but there may be restrictions in that. But I'd certainly hope they'd look into it, because that would be pretty cool. It's 15 in a second. Yeah, it's all fine. See, out of range, it's all, you know, it's feeding from the scope. That's what you'd expect. So I'm also uploading a video at the same time, so it's probably slowing it down a little bit from that. Right, so I'm just going to do some sample testing on this. So this is a 10 MHz signal with 70% AM modulation, which is always something that's just hard to lock onto. I've already preset some triggers on this, so I've already set up a window trigger, which is a fairly stable way of actually detecting this one. So I'm playing around with these trigger levels on here, not going too far. I can see it's pretty stable there. No, it's not too bad. They're not as you think to trigger on. So that's 70% mod. Now the other thing I want to check is the actual bandwidth it's will work on. I've got a BNC cable direct straight into the input, right? So there's no probe, nothing there to affect the bandwidth on the input, it's just straight in. So I'm going to turn the audio off and just do 10 MHz, and we'll check the counter accuracy, and then we will see what the bandwidth looks like as far as voltage levels and so on. Right, so modulation off, and let's increase the RF level to 100 millivolts just to give a bit of a better signal there. Let's just get this thing going. Here we go. Right, change the trigger edge. Here we go. Okay, so there we go. So it's 10 MHz signal coming in, and there we go, bang on 10 MHz. So that is dead accurate, which is brilliant. Okay, let's just increase this by 100 Hz, and we'll see if it changes by 100 Hz. Right, and yep, there we go, 100 Hz further up. So that is dead accurate. It's brilliant. So let's try going to 100 MHz. So it has dropped down slightly there, so let's just go back to 50. So 50 MHz, let's look at these, yeah, it's a bit high there, input levels here. So I've got 100 millivolts on there, which is not what I've got on here. Hold on, type. IMS. Okay, I'll take the period off. Don't want period on there, so my hands in the way, but okay, and that'll do. Right. So this is 50 ohm load, don't forget, so I'm not using 50 ohm on here right now, so it's not going to be right. That's a point, because I can't do 50 ohm loading. I need to tee this off. Hold on, let's do this. 50 ohm load. Okay. So yeah, 96 millivolts. That's much closer to the output of my generator, which says 100 millivolts. So it's still out by a few percent, but depends on the accuracy of this load. And it's probably not exactly 50 ohms, probably 51 ohms or something like that, or 49 ohms, or who knows. But that's reading 50 megahertz, 100 hertz. So it's slightly out there. But that's not too bad. So we're getting 100 millivolts. Well, 96. Let's see what we get. We get 100 megahertz. 100 megahertz is giving us 80 millivolts. Right. Let's do 100. Oh. 150 megahertz. It's 47, so it's dropped off a bit, but the count is still pretty accurate. 200. It's dropped off quite a lot there. That's in the noise. Oh, trigger's in the wrong place. It's not hopping. And there we go. 200 megahertz. But they say the levels have dropped right off there, so obviously it's not meant for 200 megahertz usage, really. That's 300 megahertz, and you can see it's right down the noise. Okay, but it's still there. You could still use it. Counter can't read it though. No, it's out of the range of the hardware counter. But okay, now I did have some bandwidth stuff on here limiting. No. Noise rejection, I did have that on or off. That's okay. So yeah, it's fine. I think it's what it is. Yep, nothing limited there. 400 megahertz, and that is, yeah, that's just basically unusable down there. Right, no good. That's 200 millivolts input, and it's just no good there. It's just aliasing and stuff there, isn't it? Let's just reach at the trigger. That might help. No, it's just too fast for it. It is what it is, really. It works fine and it's usable. So I just want to see what the cut off is at that fixer counter. So I put in a 500 millivolt. Wrong button again. 500 millivolt signal. And go to 150 megahertz again because that one works. Yep, 150 megahertz. Looks fine. 180. Yep, that will do 180. Okay, still going. 200 megahertz. Yeah, it's doing it. Maybe it's just the input level was a bit too low for it. Okay. 250. Nah, that's it. 250 is too high. It's 220 is too high. So you probably say 200 megahertz is top end for that. Yeah, looks like it's 210 there. So yeah, it's 80 and stuff like that, so it's not the best. But yeah, I mean 200 megahertz I'll say is the maximum it can do. Right, so that shows you what that part is like anyway. All fun. Okay, so feature wise, now obviously I've got the Bode plot already going on here, so I'm going to show you this first. This is a tricky thing to set up. Now you have to be really careful how you configure it, otherwise it just doesn't work right. Okay, you have to have the Siglent AWG plugged in, right? I've got a T off here. I've actually got two T's on here. I'll explain why in a reason. Why in a minute. One T comes off and goes into channel 1. The second one comes off and goes to the test circuit, right? Device under test, which is all listed under here. So channel 1 is the device under test input, which is the output of the AWG, and then I've currently got channel 3 set for the output of the device under test. Okay. Now because you've got 4 channels, you can actually test 4 sections at the same time. So if you've got like a multi-section filter, you can test each filter's part, for example, right? So that'd be pretty good for that kind of thing. And obviously plot it H1 at the same time as it's going through. Okay, so that's all pretty simple there. AWG in and out, so you can actually test. It's actually on. You can actually have it on the LAN. Not quite sure how you're supposed to configure that, but seeing as it's a USB device, I'm not quite sure what the story is here. Maybe it will share it if you've got multiple devices. Maybe they'll share across the LAN or something. I don't know. Test connection. So there you go. So it verifies it's actually considered the AWG, right? So you got amplitude, offset, units, right? So you've got various options there for that. And load. Now this is the tricky bit. Now, within the Bode plot, section here, this actually threw me for a while. I had some issues with this, and I'll explain what they were. So if you come across them, you know how to deal with it. You've got 50 ohms, 75 ohms, 600 ohms, and high Z, right? So that's fine. You look at that, okay, great. What you have to be aware of is if you set, at least in my experience with this so far, if you set anything other than 50 ohms or high Z, it doesn't work. If you set 75 ohms or 600 ohms, it will revert to high Z. Reason being, if I come out here completely and go into the AWG, the settings in here, the output loads are either 50 ohms or high Z. It's got two options, okay? Those are the options from the AWG. So anything other than that doesn't seem to work. There may be a reason for that, or maybe that I'm missing something, but that's my understanding right now, is that if you're trying to set this load option, although there's multiple options here, and there's even an adjustable one here, right? In theory you can actually set any value, right? But between 50 ohms and whatever, and infinity, right, high Z, but it doesn't actually take that setting. 50 ohms takes and high Z takes. Those are the ones that work. So choose one of those, right? Now the other thing that caught me out is I'm actually going to demonstrate this to you as well. If you're on 50 ohms setting, which is the default setting, and so I'll leave it on 50 ohms, I'll come out here. Now I've got a 50 ohm load on this, as you would have seen in my T setup. If I take the load off, so if you're doing a test circuit which may not be 50 ohms, this may catch you out. Okay, so I'll take my load off. So this is now high Z input, not 50 ohms. Now what happens when I turn this on is you'll get this error message. See? Error, please set measure range. Now this is a little bit confusing, as there is actually no way of setting it that I can find. It may be something, a feature that they're working on and they never quite finished it, or it's in development or something like that. The reason I say that is because there's also a setting in measure range, default and custom, right? So I'm yet to figure out how to change it, right? So you got default, which is what is, thing. It doesn't matter if you have this set to either way. It doesn't seem to affect anything on the effect. It doesn't seem to change anything. So I think this is probably something which is maybe being worked on at the moment. I'm speculating. I don't know. But if you've got a custom measurement range, that would allow you to set these levels and things like that to allow for that mismatch. Okay, because unless it's a 50 ohm system and you've got it set to 50 ohm, you're going to get that error message come up. It still works, but it gives you that error message. Okay. But if you've got a high Z input, then you just simply change it anyway. It's not a problem. Okay, I think it might change some calculations. It does or something. But so we'll go back over here, put it back to high Z, and that'd be fine without a load. Okay, and I can do that now with no load on, and that'd be absolutely fine. Okay, so you just have to make sure that you set that as per your test setup. Okay, so if you've got a 50 ohm system, it's fine, then you set it 50 ohms. If you're not sure, or you get an error message pop up, then change it to high Z. Okay, just that's a little gotcha, I suppose, little thing to catch you out. It caught me out for a while and it really threw me, so that's a little quirk there, so just watch out for that. Otherwise, say it works fine. Yeah, can't really add to that much, I don't think. I think I showed you everything. Options, you obviously choose which channels you're using. You can save and recall stuff. You can also do a list. Alright, so when it's running, it'll generate a list of all the test points and the relative measurements. So I'll turn it on again, and I shall do the list now. Right, it's already on, so that should fill up the list. I've got it set on channel. I've got it on the wrong channel. That's why it's nothing coming up. Channel 3. Alright, so there you go. It tells you the phase and the amplitude of each test point and the frequencies. Okay. Yeah, I've actually got a bit of a funny glitch here at the 58 Hertz. Our mains frequency is 50 Hertz, so I'm guessing it's probably some mains interference noise coming in, because I've got a crappy test circuit here. It's not good. Alright, so that's why I've got this little weirdness going on in places, and because I'm touching it, I'm affecting it as well. So, but yeah, that's the Bode plot, and it does work. it just takes a bit of getting used to. I've spent a few hours just getting head around it. If you've used it before, then you're probably fine. For me, it's a new thing. And as you can see here from these waveforms, you see the actual phase difference in here. So if you wanted to do a measure on that, you could do it. Yeah, cursors. There we go. I'll come back. So I've got two waveforms here, as I was saying just now. I had to stop because I couldn't find a setting. I had a bit of a mind burp, I suppose. So under measure, you've got the types you can set in here. Okay, and what you have to do is you come in here and you set the channels for each source. Right, so it's channel delay, source A, source B. So you choose which channels you want, and then you can choose which function you want. So in this case, I'm looking for phase. So I've set that up, and we'll get out of there. Oh, put it back on. So 51.8 degrees or so, 52 degrees is what it's showing for this. So that seems interesting. So let's go and look at the Bode plot and just see what that says in comparison. Bear in mind this is at one frequency, which is 100 Hertz. Okay, so 52 degrees at 100 Hertz. So what I'll do then is come in here, 100 Hertz, got 101 here, 52 degrees. There you go. It matches. So ignore the glitches I was saying before because I was messing with things and it's not a great test setup, but it shows that hey, you can easily look down the chart here and see what's there. If I can get into the list, there you go. Is that one? Yes, it is. So you can scroll through the list, and when you're in this particular menu, this Bode feature, Bode plot feature, it's quite a intensive option. So it uses a lot of memory and power to, processing power to actually work. So it does get a little bit less responsive in this mode when you're doing Bode plots. It's okay, but it's manageable. You just have to expect it to have to think a little bit when you're doing things, depending on what you're doing. Right? I'll turn this back off again. So yeah, it works fine. So I can't remember if I showed this or not in an early part of the video because I'm doing this in pieces. This is the search function. Now this allows you to find the trigger edges very easily. So anything which is causing a trigger, it puts a sort of flag on it, and so you can see where they all are. So if you've got a complex waveform, you can see where the trigger step is. So what I could probably do actually is go into the wave generator, go to a arbitrary wave or something, which is maybe a bit less specific. Equal. Yeah, here's an arbitrary waveform. Right. So you can see all the trigger points across there, and that shifts on there. Hold on, what am I doing wrong here? You can start DC on it. Yeah, I've search function threshold is what I'm supposed to be changing, not the trigger level. Right, so have I got this on something silly? Yeah, that one there. Right, here we go. So I haven't used this that much myself, but you can see here from all the pulses here where it's triggering. So, and from there you can set the point where it's going to show up. So it's quite handy as well if you want to sort of try and figure out what's going on with something. Maybe if you've got a digital signal or something like that, I imagine it works on that too. I haven't actually tried digital inputs because I don't have an input here. So it has here S bus just under there. To the back, is it? Right, just there. So it looks a lot like an HDMI connector, but it looks slightly different. It's very similar. It looks very much like an HDMI connector, but it's not. That's for the 16 digital channels for the MSO option. That is an option. This isn't included with, well, the unit I have here doesn't have it, but it is a planned option. I'm not sure if it's actually released yet or not, but it's there. You plug it in, you got a 16 channel logic analyzer. That's what I'm looking for. So that's another great feature to have too. Now 16 channels is a lot, for something like this. And that's got the digital stuff on there too. So let's get rid of that. Get rid of that. And again, you can hide that menu and do stuff with that. So if you need some more screen space, measure. I tend to have measure on actually. Maybe stats on, right? But if you want to hide that, it shifts it all down. I don't know if I showed that either. I think I've covered just about everything now. Decoding I haven't covered. This may or may not be able to make sense of this. It's not actually raw data, is it? But I don't know. Will it or won't it? Probably not. So it's not actual data, so it's not surprising it doesn't make sense of it. I don't know. Maybe we can do it with something else. Not configured though, so maybe not. Anyway, so it does, decoding built in. I think I already mentioned that though. So it does a lot of stuff, and it's a really cool little unit. Some of these features are a little bit hard to get your head around. Like I say, the Bode plotting, that's a bit tricky. I have trouble getting my head around that and just figuring out how to use it properly, and the little glitches there with the description of the error, which is a bit misleading. But yeah, I mean it works. So yeah, I think it's not bad. I had 4 channels set up on my measuring this piece of test gear just here, which I'm in the process of repairing. So this was a Fluke 5200A AC voltage calibrator. So I had all 4 channels hooked up to that and doing some testing and just showing how it works. Anyway, so I think that's the end of the video. I can't think of anything else to cover. I don't think I've missed anything. I may have done. I probably have actually. This does so much stuff. Actually, save recall. Have I gone into here? Recall. We can do recall setup, so you can recall like factory setup. We go to reset it. References and setups, like you can do that, and you can save various functions in here as well. Save the setups or reference for like the reference waveforms, and you can do screenshots and data logging and like so. Yeah, anyway, there's lots of stuff. So that's fairly common. It's expected these days in scopes. So thanks again for Rob for lending me this unit, and don't forget to see him or get hold of him if you're interested in one of these. And at least if you're in New Zealand, there you go. There's his card again. And don't forget to subscribe and click the like button if you like the video and liked seeing it. I'm going to have the scope with me for a little while. I'll probably carry on playing around with it, and maybe I might even do a follow-up video if I find anything else to add to it. But if there's any questions about it, I may be able to answer them if I can do it. I'm not super technical, right? I'm more, figure it out as I go kind of thing. So if it's a super technical question, I may not be able to answer it, but by all means ask anyway. And if I might be able to address something or replicate something, or something like that, we'll see. Right, so that's the end of that. Don't forget to subscribe and give us a thumbs up and share it and that sort of stuff. So catch you later. Bye.